Let us solve objective 1 concepts of physics textbook problem electric field and potential topic. First question. Figure shows some of the electric field lines corresponding to an electric field. The figure suggests that in options it is given that regarding to electric field intensities. Electric field intensity strength will be stronger if electric lines of forces are very near to each other. And electric field intensity will be weaker if electric lines of forces are separated far. At point A and C, electric field lines are nearer compared to at point B. So that electric field intensity at A and C are greater than the electric field intensity at point B. But electric field intensity at A and C are equal because at A and C, electric lines of forces are separated by same distances. So that at point A and C are electric field intensity greater than electric field intensity at point B. So that for this question, option C is correct. Second question, when the separation between two charges is increased, the electric potential energy of the charges. Electric potential energy between the charges formula is U is equal to K Q1 Q2 divided by R, where R is the distance by which they are separated. Let us take case 1. Case 1 is if Q1 and Q2 are same sign or same sign if you take, then by increasing R, if you increase R, potential energy will be decreases. By increasing R, potential energy will be decreases. Suppose if you take case 2, in case 2 we are taking Q1 and Q2 are opposite sign. Opposite sign. If you take opposite sign, then potential energy will be negative. Potential energy will be negative. By increasing R, potential energy negatively decreases. That means potential energy increases. Potential energy increases. So that when distance between two charges are increases, if charges are same sign, then potential energy will be decreases. And if charges are in opposite sign, by increasing distance between the charges, potential energy will be increases. So that by increasing the distance between the charges, potential energy may increase or decrease, depends on sign of the both charges. So that for this question, option D is correct. If a positive charge is shifted from a low potential region to a high potential region, the electric potential energy. Actually, electric potential energy, also known as work done to move a charge from certain final potential to from initial potential to final potential. That means electric potential energy is equal to work done formula charge into change in potential. So change in potential, we can take final potential minus initial potential. Here final potential greater than initial potential is given, so that this is positive, and the charge also positive given, so that this change in potential energy is positive. Change in potential energy positive, then potential energy is increases. So that when positive charge we are moving from lower potential to higher potential region, then potential energy of the system increases. Potential energy of the system increases, so that first option is correct. Two equal positive charges are kept at points A and B. The electric potential at the points between A and B is situated while moving from A to B, the potential. Actually, here given that two charges are there, let us assume this is the charge A and this is charge B. These are separated by the distance R. Actually, we know the formula for potential is KQ by R. Let us take a point very near to A. If we take point very near to A, R tends to 0, so that potential very near to point A will be infinity. And if you take point near to B, this point near to B means at this point potential is infinity will come, because this point very near to B means R we are taking almost 0, so that nearly infinity comes. That means at point A potential is very higher, similarly at point B also potential very higher. So that when we move from A to B, potential should decrease and then increase. Then only at point A also very greater and point B also very greater. So when we are moving from point A to B, potential should decrease and then increase. So for this question, fourth question, option D is correct. The electric field at the origin is along the positive x-axis. A small circle is drawn with the center at the origin cutting the axis at points A, B, C, and D having coordinates a, 0, 0, A, minus a, 0, 0, minus a, respectively. Out of the points on the periphery of the circle, the potential is minimum at. Actually, we know that potential decreases along the electric field. Let us take this is the y-axis, this is the x-axis. This point is the origin. Let us mark here. This point is a, 0. This point is this point is a, 0. This point is 0, a, and this point is minus a, 0. And here we are taking as this point as 0, minus a. Now we are going to draw this circle. Listen, this is the circle we assume. Like this, we have drawn the circle. And here given that electric field is given in the at the origin is along positive x-axis. So electric field is along positive x-axis. We know that potential will decrease along the electric field. So potential decreases along the electric field means from, let us take this is the point D, this is the point A. From D to A when we move, potential decreases, so that at point A only potential will be minimum. So for this case, we have to assume, we have to consider that potential decreases along the electric field. So when we move along the electric field at point A only, potential is minimum compared to all other points. So that potential is minimum at point A for this question, correct answer. If a body is charged by rubbing, its weight remains precisely constant, increases slightly, decreases slightly, may increase slightly or may decrease slightly. When we rub one body with respect to another body, what happens means electrons transferred from one body to another body. Let us assume this is the body A, this body B. When we rub this body A with respect to body B, electron, if suppose we assume that transferred from body A to body B, that means some matter lost by the A, some matter gained by the body B. So that the body A becomes, it is become positively charged by losing electron whose mass slightly decreases, and body B gains negative charge whose mass slightly increases. So that when we rub two bodies, the body which loses electron, that body loses matter, so that whose mass slightly decreases, so the weight decreases, and the body which gains electron, that body gains some mass, so that whose weight slightly increases. So that here for this question, when body is rubbed, whether it is gained electron or losses electron, we don't know. So that if it is gained electron, its weight increases. If it losses electron, its weight slightly decreases. For this question, may increase or decrease slightly, may increase or decrease slightly. So that for this question, answer is fourth option. An electric dipole is placed in a uniform electric field. The net electric force on the dipole. When we place electric dipole in the uniform electric field, let us assume this is the uniform electric field. Uniform electric field means electric field intensity at each and every point whose magnitude and direction constant. So if you place here negative and positive charge, negative and positive charge separated by certain distance is known as dipole. So like this dipole is there. Now electric field will exert force on positive charge along the electric field, that is EQ, and on negative charge force will be exerted by the electric field opposite to the direction of electric field, that is EQ. Now on dipole placed in uniform electric field, that means electric field at the point on the negative charge and electric field at the point on the positive charges are equal, and this charge dipole, two charges are equal in magnitude in opposite direction, so that these two forces acting on the dipole are equal in magnitude but opposite in direction, so the total force must be 0. So for seventh question, the answer is always 0, so that for seventh question, first option is correct. Consider the situation of figure. The work done in taking a point charge from P to A is WA, from P to B is WB, and from P to C is WC. Which option is correct? We have to check. Actually, to find work done, what is the formula means? Work done formula is equal to charge into potential difference. Final potential minus initial potential. Initial potential, we have moved from point P to point A, point B, point C, like this. So the V we taken as a final potential, VP taken as a potential initially, that is at point. Since charge moved from point P to A, B, C. Now listen here, this A, B, C are equal distance from the charge Q. So that potential at A is equal to potential at B is equal to potential at C. So So that when we are moving the charge from point P to point A or point P to point B or point P to point C, potential difference equal. Since potential difference is equal, so that work done in moving from point P to A, point P to B, point P to C are equal. So that work done to move from point A to point P to point E is equal to point B is equal to point C. So for this question, correct answer is third option is correct. A point charge q is rotated along a circle in the electric field generated by another point charge q. The work done by the electric field on the rotating charge in one complete revolution is actually work done by the electrostatic force in a round trip is 0 because electrostatic force is conservative force. Electrostatic force is conservative force. Conservative force means work done by the force in a round trip must be 0. Since here we are moving the charge in the electric field only, so that conservative field produces work done in a round trip 0. So for this question, answer first option is correct. Work done in a round trip is 0.